Well, here we are again with one of our science extracurriculars. And it's Sunday, so we're going to try and finish up some of our old business, things we've taken out of the can and we hadn't fully finished. Now, a few weeks ago, we were talking about gravity on the moon and how one of the first experiments that was done up there was to drop a hammer and a feather and to see if they fell at the same rate. We were working with pushes and pulls and Newton's laws at the time, but I hadn't pulled out my evacuation tube. And so here's what we're going to look at here with this tube. If you look closely, we'll pull it all the way in. Are we in focus, Ryan? You see there's a coin in there. There's a pink piece of paper about the size of a coin and a little downy feather. And this has oxygen in it. I'm going to pull back so we can see the whole thing. And what I'm going to do is I'm going to flip this over, and then gravity's going to take over and pull these three items to the bottom of the tube. And as we expect in the air, and there's air in this tube currently, they fall at different rates. In fact, it took the feather quite a long time to reach to the bottom. Do we get that on camera, Ryan? Should we do it? Look at it again? Look at it again for those of you that had your went away for a sandwich or blinked. So there was an order that time. It was penny, pink piece of paper, downy feather last. Well, let's draw some of the oxygen out of there with this vacuum pump. We won't be able to get it all. We will be able to get a lot of it. Turn that on. What kind of vacuum we can pull with this thing today. As it tightens up, I can feel everything tightening up on that tube. Again, our pump is only about a third of a horsepower. So we've only got a third of a horse pulling on this thing, so I don't think we're going to get too much more of a vacuum than that. Looks like my gauges are stuck and stuff, so I'm going to lock that pressure in. Turn that off. Pull the tube on there, and we should have a tube that has most of the air taken out of it. Let's see if I can get those spread out so they don't fall on top of each other. They're not even acting normally in there. They keep wanting to stack on each other. Spreading them out, it's tricky. All right, they're spread out enough, I guess, now. Let's see if we can tell a difference in a tube that doesn't have, well, the downy feather is still showing that there's air in there. But the two pieces of paper, are they falling near about the same rate? The feather's falling faster, but it's still not gonna, it's not evacuated enough for that downy feather to make a difference. Let me see if I can pull a little bit more air out of there. Sometimes the second try is better than the first. Oh, there it goes. What do we got here? I still got the mare and a lazy pump. Still putting out a little bit more. Lock that in, shut it off. Let's see if we can get it. That downy feather is the one that's being stubborn on us. The three are well spread there, so let's try it again. Oh, they stuck. It's stuck. I see what's going on there. It's sticking by electrostatic attraction. Let's see if we can have that happen. Not happen. Well, the downy feather is falling faster, but we haven't got a complete vacuum, and I wanted you to hear, in fact, the air go back in. There was the air returning to there. Now, we walk through this sea of air as though it's not here sometimes, but you have to remember that it has mass, it has weight, it has substance, it has molecular integrity. Well, what is it? What is this air we live in? What is it made of? I mean, most of us know what we need up here. We need oxygen. And that's about 16, 18% some days, 20% others, perhaps some places, of the air. So there's a whole 80+% that's actually things we don't need to survive. We don't need the most of the air, which is about 4/5 of it, nitrogen, at least to breathe. We use that nitrogen to grow plants and to, as part of our holding the thing to the surface of the earth, the weight of it. But those are the real, we don't really need it. There's some other things up here. There's some argon up here, a little carbon dioxide, water vapor, the various chemical experiments the humans have going on. There's a little bit of methane. A few other things out here, but for the most part, It's oxygen and nitrogen. And when we think about how much it weighs, sometimes we forget that, you know, the air in one of the rooms of our house weigh about as much as we do. So if you want to get up in a balloon and go into the sky, you have to have one, you know, the size of your house to lift up a couple of you. So that's something to think about. This thing, we're going to turn on and get that flying, get that going, see if that's going to happen. Well, we're going to do a couple of things that have to do with air. Park this over here. And see if we can't figure out some things about pressure with things that we know. So how much pressure is this air? What is it that creates that pressure? Well, you think about this atmosphere we live in. Space is about 60 miles up or so. And as you get higher and higher into the atmosphere, the pressure and the weight of that air gets less and less because there's less of it on top of you. So at sea level, it's about 14.7 pounds per square inch. So that means every square inch, that's about a square inch, has 14.7 pounds pushing on it at sea level. Now, we take our experiments up to the top of a mountain, and there's less air on top of us because we're up a mile maybe. And so it has lower pressure, it has less oxygen, and so that's why sometimes athletes that train in low oxygen and then go to a place where there's more oxygen can do substantially better because they're used to working on at those lower air pressures and oxygen levels. I'm trying to get my candle to burn a little bit more robustly. I'm pouring some water into here, just colored blue for the experiment's sake. I'll put a little more in there. Candle's still not quite there anyways. And we're going to see if we can't make this thing show us something. All we've got, if you want to try this at home, by all means, it doesn't have to be this shape. I just like this shape because it seems to work well. A candle standing up in a shallow pool of water. And then we're going to try and figure out why what goes on goes on. So I'm going to put this over there, and those of you that are watching at home or guessing along, if you will, you know that that candle is eventually going to run out of what it needs to burn, which not the nitrogen or the water vapor or the argon, but oxygen. So let's put it over there. I think we've got it going well enough. Still has oxygen. Okay. We're getting a water pressure rise already. And the candle is still burning. And still burning. Because there was quite a bit in there, and the water is still rising. And now the candle goes out, it ran out of oxygen, and the water is still rising. As it kind of, I used to have a Franklin form flask that used to do some interesting things when we did this. Let's see if we can get some interesting things going on. And this is also a hint as to what's going on. We'll hope the vessel can take it today.
That's ice that you're putting on?
That's ice I'm putting on top of it. I don't know if it's making much effect. I haven't been watching as it's going. But it will give you a hint as to why the water should keep on rising. And it is still rising even after the candle has gone out. It's still rising a little bit. I think it might be done. We might have reached our full rise on that. Well, why? What went on? I mean, I'm used to an audience either guessing right or wrong. Well, what happened here, Ryan?
So obviously,
a couple things too.
You have a pressure differential that's happening there.
I did create a partial vacuum there. Yes, I did.
So the water's getting.
So when the candle was first burning, yeah, it was heating up oxygen molecules and nitrogen molecules, and some of them were actually escaping out of the bottom here from the pressure there. So I had created a minor vacuum.
And so the candle consumes the oxygen.
Some of it, yep. But it also created carbon dioxide, so it was given something too.
So I was going to ask, because
it didn't just go away. It's kind of stuck in there.
The oxygen puts that waste product for it.
Right. So some of the carbon came from the candle ingredients. But what also happened was we had that sort of pressure rest where it was comfortable with the heat of the air molecules that were in there. They were pressed out. Well, when the candle went out, it started to cool. Gases cool quickly, and so cooler air takes up less space. So we created even a tighter vacuum, and I think we did get a little bit more rise, and this actually helped cool it down a little bit. Now we can actually make water boil with ice if we get the right flask. A Franklin flask will do that. So we'll let that one go back down there.
So
the ice
the
just
combination of the candle going out and there no longer being a flame in there, and the ice on top is cooling down the air.
cooling down the molecules. So sometimes you have to look past the first reason to the second reason when you can figure out what's going on. This is something I haven't done for a while, and I didn't practice this one either, so we'll see if that works. It seems to me like I used to use this thing. I'm just resting that there. And we're going to do a similar thing. This is one that's fun to do. If you get a bottle like this, save it. I mean, these are hard to find. Or if you don't want it, bring it to me, because I like bottles like that. It's a good size. And we're going to put a candle in, a piece of match in there, pretty good match. It's going to burn out, and then let's see if we can get it to do its thing. I don't know, Ryan. I don't know. Will it do it?
Work after the
It might keep going.
match
It might
is
keep
gone
going.
out.
Let's try something else. Let's do a double trick on it. It sealed the bottle, but it didn't. I think we needed a bigger flame in there. Let's take a look down here. We'll keep an eye on that one.
So why did you wait until the match went out before you put the
Well, I thought it was still going to get more air out of there. I can try that. Let's try that again. Let's see if we can. Well, it's starting to cut.
trying to smash her?
It's trying to get itself in there. It's just not quite. I think I need to get small eggs or something. Maybe in my bottle is. Well, let's try it. Let's just have it back. Oh, there it went. All right, that's not what we want. Let's try that one again. Let's try it. Let's try it by not putting out the can. All right. More than one way to get an egg out of a bottle. Let's try putting the rest, the sort of the rough egg in there. See if we can get it. I hate not making a thing work. I've done this before and I know it works. Let's try. Let's try a couple of matches. I like more flame. I think more is better in this instance. And then we'll put it. Alright, that time we got it to go down. Alright, so yeah, it seemed like putting it on right away was the way to go with that. That seemed to help it out a little bit there. Alright, oh, we didn't fail. That's good. You can do this stuff 10 times right in practice and then bring it out here in camera and it can go the other way. Well, maybe this is boiling up. Let's see, we got heat coming out of there, heat coming out of there. Probably less heat coming out of here than any of them. So, I don't know if this one will even work. We'll see. So, again, we've got cans, and I've been saving my cans for a while for this show. Not just for this show, but for this kind of a thing to do. And what we've got is that they're on the hot plate, 540 degrees Celsius, good and hot, well over the boiling point. And they're starting to boil in there. Oh yeah, I hear them boiling, I smell them boiling, I can feel them boiling. And as they do, that water vapor that's gone into a gas is pushing the air out of these cans. I don't know if that one's going enough. I hate to not do that one. Let's see if we can keep that one going. So I'm going to try this one first, not this one, but this one. This one feels hot, but not quite as hot as I want to go. So we talked about 14.7 pounds per square inch, and there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's at least 140 pounds on each side of this, and on the so now there's 300 pounds of pressure easily all over this can if we get a total vacuum. So let's see what happens. We're going to turn that over into the cold water, and then the gases in there are going to cool quickly, and we'll see what happens. Predictions?
bigger?
It just goes when it goes. So we're
In there.
some kind of a crazy thing happened there at the end. It's exploited a seam break or something,
Yeah.
and sucked it. In fact, it sucked up a bunch of water. before it did that. So let's put, there's still some strange things going on in this can here. It won't let the water go back down. It's like it's got a vacuum in the top of it still, so it won't let that water go down. That other can is going now. Let's see how that should, well, that can acted weird. We'll see how the big can goes. This one seems to be boiling now. Oh, I'm on an ice cube. I heard it go, but I didn't see it go. I actually heard a sucking of liquid more than I heard a collapsing of cans. We've actually done this with a 55-gallon drum. That gets exciting. And it's tension filled because it takes some time, and then it goes. This one's boiling good and good. Let's make sure we got a good hot boil going. Seems to be going well, huh, Brian? Oh, look at that appetizing
steam
treat.
coming out of it.
Water's still cold. Hopefully we can end this with our festive. Oh, that was a good olive oil. I remember that one. I did consume all of these olive oils. I like the Spanish olive oils. We got a good boil going. Well, let's give it a try, Ryan. Some ice cubes out of the way. They seem to.
Hopefully the can is of the same caliber as the olive oil.
Maybe this was medium quality. This was high quality. I like the Spanish ones. They tend to be a little more flavorful, fruity, if you will. Yeah! We didn't count up the pressure, but we did get a nice collapse on that can. That's our show today. We're going to talk about whatever we get to this next week. We're going to come up with some more programs for you. The Virtual Science Center keeps on virtuating.
It's me tomorrow doing a show. To be determined. It's kind of how it goes a lot of the time around here, but hopefully I'll see you tomorrow and you can come and see whatever I do.
Yep, we'll do the Virtual Science Center visits this next week too, so we'll take care of some other things for you. So stay tuned, 3:30.